Hi, I'm Sam Miller. I'm with the Habegger Corporation here in Columbus, Ohio. And today I'd like to speak to you about a safety measure that was put in place to keep houses from freezing in the wintertime if somebody moves out and turns the heat off. If they turn the thermostat off, turn that off, there's nothing to keep the house from freezing. You put in place a temporary stat, or a temp stat as the brand name is called, and you hooked it up in between the red and the white wire. And basically what it does is it's supposed to be a 55 degree thermistor that at 55 degrees it closes and brings the heat on, and that way keeps the house above freezing and won't allow the pipes to freeze. Now, we ran into some issues this summer with the heat being on along with the air conditioner, and with the two of them fighting together causes some high electric bills, and that's not the purpose of the stat. What do you guys need to know to check this? So we're going to go through today how to check this out. They're supposed to close at 55, sending power through to the W terminal, bringing the heat on. The first thing we want to know is this actually closed when it shouldn't be? So I've got a couple meters here that we need to do these tests. The first is a voltmeter with continuity, and that continuity just means that when I run power through something, you can hear it beep, it means it's making connection. So the first thing I'm going to do, and I've got alligator clips on these to make it a little easier, is I clip the thermistor in there, and you can see with it clipped, we don't have any continuity through it. So this, in the ambient temperature, is open. To determine whether how this is operating, I'm going to take a thermistor tied to a thermometer or temperature sensor here. I took the cap off, put the thermistor back inside there so that we have a good thermal mass so that I'm reading the same temperature. You can see that this is hooked up. Kind of a strange place to do a video in front of a refrigerator, but we need that to change the temperature. So we're going to place that in the refrigerator, and that will lower the temperature. So let's take a look here at what we've got. You can see it was reading 80 in my hot little hands. So it's going to take a moment for that thermistor to come down to temperature. Okay, you can see, oh, it just went off at 58 degrees. So that tells me that this thermistor is reacting a little quicker than 55. So if I'm in the environment and it's 58 degrees, that's going to close. Now you've got a lot of these put into a closet with the air handling equipment. By having that situation, if there's any air leakage out of the coil, out of the unit, out of the fan coil or furnace, you're going to have a lower temperature than 58 degrees. It's going to bring the heat on, especially if this bulb is in direct line of that air movement, or just in the closet alone with that closet door shut. It can get pretty cool in those closets. So that is a good possibility of why you're bringing the heat on with the cooling, okay? So let's recap a little bit, see what we've got. This thermistor is designed to protect you during the winter time from the house freezing if somebody turns the thermostat off, okay? It's supposed to bring the heat on at 55 degrees. We checked this one and saw that at 58 degrees that it closed and brought the heat on. If this thermistor is in an environment that is cool enough to bring it on, it's going to bring the heat on. We can't stop that. So let's do a couple things. Let's make sure that these are not in a cold closet or in the airstream that is going to get cooler. And also, we need to make sure that it's not closed on its own, that it is operating properly, that it opens and closes. I hope this gives you a couple ideas of how to check these thermistors out and how to keep from having high electric bills due to the heat and air conditioning being on at the same time. My name's Sam Miller. I hope this video helps you do a little troubleshooting. We'll see you in the future. Thank you.